Finding the limit of different expression tutorial. Part 1.
Hello everyone! Today we are going to solve the limit. The limit of 2x squared minus 6x over sine 2x as x approaches 0. We're going to solve this step by step, slowly, and with clear explanation. Thing we always try in solving limits is direct substitution. So let's substitute x to 0. Let us now substitute the 0 to our given limit. 2 squared minus 6 times 0 over sine 2 times 0. Next is the 2, which is multiplied to 0 because 0 squared is 0. Then minus 0 over sine, open and close parenthesis, 0. The clear answer would be 0 over 0 because this is an indeterminate form, which means the answer is not yet defined. Now that we know that direct substitution will not work, let's do the other way to solve it, which is the factoring the numerator. From our given equation, let's take the numerator then factor it, which is 2x squared minus 6x. Since both terms have a common factor of 2x, we can factor it out and it will now become 2x, open and close parenthesis, x minus 3. Now, our expression becomes 2x, open and close parenthesis, x minus 3 over sine, open and close parenthesis, 2x. By factoring our numerator, the solution becomes more easier because it reveals the term x, which we will later match with sine 2x, allowing us to apply a trigonometric limit formula. Now that we factor it out, our next step is to separate the expression. For our expression, we can separate this 2x over sine 2x from this parenthesis x minus 3. Now it will become open parenthesis x minus 3 close parenthesis minus 2x over sine open and close parenthesis 2x. We separate it like that because we want to use this important limit identity, which is the limit of 0 sine x over x equal to 1. From our separated expression, we can now move on to matching the identity from the given open and close parenthesis x minus 3 and 2x over sine open and close parenthesis 2x. Let's focus here. 2x over sine open and close parenthesis 2x. Right now, we have 2x over sine open and close parenthesis 2x to match this with the limit identity. We rewrite it as the reciprocal, then it will be 2x over sine open and close parenthesis 2x is equals to 1 over sine open and close parenthesis 2x over 2x. So now, our entire expression becomes open and close parenthesis x minus 3, 1 over sine open and close parenthesis 2x over 2x. Now, we have a new expression. We can now apply the limit. We stated earlier that our important limit identifier is limit is equals to sine x over x is equals to 1. From our expression open and close parenthesis x minus 3 and 1 over sine open and close parenthesis 2x over 2x, we can see that we can apply this limit identity here in 1 over sine open and close parenthesis 2x over 2x. So now, it would become 1 over 1. Therefore, the answer is 1. Now, our limit becomes the limit of x minus 3 multiplied to 1 as x approaches 0. For the last step, we can now do the substitution. Substitute x to 0. The limit of x minus 3 multiplied to 1 as x approaches 0. Substitute the 0 to the variable x. So 0 minus 3 would be negative 3 multiplied to 1. Our final answer is negative 3.
Part 2.
Let us solve the next expression. The limit of x cubed minus 1 over x minus 1 as x approaches 1. First, we try to substitute 1 into the expression. If we do that, the numerator becomes 1 cubed minus 1, which is 0. And then the denominator also becomes 0. That gives us 0 over 0, which is indeterminate. So, we need another method. Let's try factoring the numerator. The expression x cubed minus 1 is a difference of cubes, so it factors into the quantity of x minus 1 multiplied to quantity x squared plus x plus 1. The expression becomes x minus 1 multiplied to the quantity of x squared plus x plus 1 over x minus 1. We can now cancel out x minus 1 from the numerator and denominator. After cancelling, we're left with x squared plus x plus 1. This expression is continuous. So now we can substitute x equals to 1. When we plus in 1, we get 1 squared plus 1, which is equals to 3. Therefore, the limit of the given function as x approaches 1 is 3.
That's how you find the limit of x. Thank you for watching.